Drones provide a cross-scale opportunity to link field-based and satellite-derived data sets. This is particularly relevant to broad-scale vegetation patterns like the greening of the Arctic. While there's multiple lines of evidence validating vegetation change across the Circumarctic, there's also substantial heterogeneity in these patterns, both spatially and in temporal characteristics of these trends. If we look at these samples of tundra landscapes from all around the Arctic, we can see that in MODIS and Landsat time series, some of these sites correspond very closely. Others correspond in a similar direction, but there's a bit of an offset. Whereas in still others, we see both greening and browning happening at the same location. How much of this can be attributed to scaling biases or other factors is something that we can investigate with a fine-grained data set. And that's what we have with the High Latitude Drone Ecology Network, a hugely collaborative effort with 50 plus researchers contributing data to help generate 73 Arctic landscape maps across 18 different regions. They span multiple latitudes and ecological environmental histories, and climate space, and kind of spatial structuring of the environments. The big advance in the application of technology here is not using drones or drone-based sensors per se, but using them with consistent protocols in a manner that allows for ecological differences across sites to be emphasized rather than methodological differences. And in so doing, we can generate consistent products that allow us to compare correspondence through space and also explore scaling relationships. So we can see that Sentinel data correspond more closely with the fine-grained drone data sets than either Landsat or MODIS. And perhaps this isn't surprising given its finer grain, but I also want to emphasize that we're still processing for bottom of atmosphere for some of these sites. So I expect this relationship to even improve through time. What's important here is demonstrating that this relationship is robust across a very wide range of sampling sites, not just a single location or region. However, this is looking at just a central tendency of a 9-hectare plot, which is a little bit larger than a single MODIS pixel. There's also the clear and expected loss of spectral variability with aggregation. This is widely known in the remote sensing space, but we can conceptualize it at a grain of ecological dynamics at this point, looking at individual communities or even plants in these data sets. And so thinking about the spectral distribution in the environment and what it represents and what is lost. And so while the central tendency may be similar between drone and Sentinel data sets, you see the tails of these distributions can differ substantially from one another. This is particularly important when we consider that transfer functions are often nonlinear when they transform spectral information into more biologically meaningful information like biomass or LAI. And it's the tails of these distributions that can have outsized effects on the patterns that they generate. This shows the previous NDVI data transformed into biomass using generic density function, and how the different distributions can impact the nonlinear transformations of biomass estimation across these diverse sites, both texturally and contextually. The drone data can reveal the context of vegetation cover, topographic context, or even microclimate context beneath the grain of satellite pixels. And this allows us to partition the spectra and scale these specific areas using ecological expectations of how they've either changed in the past or will change in the future. This offers the most exciting opportunity because, again, of the cross-site variation in these data sets. To summarize, this network provides an opportunity to explore variation in correspondence and scaling across the diverse tundra biome. This will be critical for both forecasting and hindcasting carbon dynamics and vegetation change throughout the region. We thank the multiple funding agencies and institutions that have supported this work.